Welcome to the Omar Aleli podcast, your go to podcast for exploring the diverse fields driving space exploration and technology. I'm your host, Omar Aleli, and today I'm thrilled to be joined by Paolo Ferri, the key figure behind some of Europe's most ambitious space missions. As the former head of mission operations at the European Space Agency, he's overseen operation, preparation, and execution for all ESA unmanned missions. Post ESA, he remains deeply involved in shaping the future of space exploration through authoring books, teaching, mentoring, and advising various aerospace companies. Paulo, thank you so much for taking the time to be here today.
Thank you for the invitation.
Paulo, you have dedicated your life to the space industry, particularly to the development and advancement of the European space program. Can you start by sharing with us a brief overview of your path at ESA, which led you to heading ESA's mission operation department?
Yes, my background is science. I'm a theoretical physicist, and after university, looking for jobs, I was always dreaming of space. And I saw an advertisement on the newspaper. The European Space Agency was looking for young, relatively unexperienced astrophysicist. I was not really an astrophysicist. I had followed a course of astrophysics in school, in university, but I applied, so I got a fellowship for 1 year, and I started as a scientist, but in support of the scientific operations of a spacecraft which was called Exosat,
Hmm.
and it was an X-ray observatory. This was mid 80s.
Hmm.
So I got in touch with mission operations, and this was love at first sight. So when 2 years later I got the opportunity to move from the scientific operations world, scientific directorate of ESA, into a more permanent job, but in a different directorate, which was
Hmm.
the operations directorate, I
Hmm.
moved into it. I worked on as an operations engineer, although I was a scientist at that time, on a mission called Eureka, and then my career developed from there. In '93, I got the responsibility for my first, say, team leading responsibility for the operations of cluster, which then exploded in '96 at launch. So I moved on Rosetta, and Rosetta, which is a cometary mission, is quite famous because it's the only mission that landed on a comet. Basically followed me for 20 years. But in the meantime, I developed my career. I became responsible in 2006 for the division in the operations department that dealt with interplanetary missions of the European Space Agency. And then in the last 8 years of my career, which ended in 2020, I was responsible for all operations of the robotic mission. So practically, I did all the jobs in the operations department at the European Space Operations Center in Darmstadt in Germany.
Very exciting. So, when things get tough, which in our industry they tend to do, right? Is there a moment or event that sustains you and reminds you of why you have chosen this path in the first place and why it's worth it? In other words, what is your lighthouse when the night is at its darkest and the sea is raging, so to speak?
Well, uh, actually, there is not really a specific moment, but the passion for space was born with me when I was 9 years old, and I saw human beings landing on the moon. And of course, this sort of childhood dream
Hmm.
is always present in my mind. And the tough moments can occur in the operations room especially in the first part of my career, the first 2/3 of the career, I was living in the operations room day and night, weekends, and you can have difficult moments there, but the excitement and the adrenaline of those moments uh, keeps you really focused, and of course you still go back to the fact that you are actually living your dream of the childhood.
True.
The other difficult moments, like the ones which are more managerial, the difficult periods of development, maybe some complications, financial issues, and so on,
Hmm.
of course, are a bit more detached from space, but
Okay.
somehow you get over them as well.
You've once said that ESA's collaborative model is unique, multiple nations pooling resources and expertise. from your vantage point, what do you consider ESA's most enduring legacy so far? And how do you see it evolving in the coming decades?
Yeah. Well, the agency evolved. In fact, when I joined, the agency was still relatively young. Yeah, formally only 9 years old when I started. But the agency evolved from a purely scientific endeavor. It was basically a bunch of scientists that got together and started doing science in space.
Hmm.
And you could still feel it very strongly in the 80s. This feeling gradually and throughout the 40 almost 40 years of my career. Of course the agency had to evolve because space
Hmm.
was evolving. Space industry when I started was really almost not there in Europe,
Hmm.
and thanks to the agency space industry developed, and that's, I think, the real big merit of the European Space Agency. It helped creating a true and a competitive space industry at world level, not only in one or two countries, which maybe had already the start and had the funds and had the resources for that, also the human resources, but it created this industry spread all around Europe. Also, thanks to its policy, the famous heavily criticized geographical return rule of the European Space Agency was the
Hmm.
key to develop this type of industry. And I think that's beyond the certainly undisputable scientific achievements,
Hmm.
fantastic missions. I think what really ESA managed to create was a true and strong space industry, which today actually can go on its own in many areas. We don't need, if you want, the guidance of
Hmm.
the agency for many aspects of space because industry can do it on their own.
So, for listeners new to the space sector, let's start. Let's briefly set the stage. What do you mean by space mission operations, and why are those operations such a critical backbone for any space endeavor?
Yes, but particular people that just see space as maybe some pictures of a launch in the beginning of a mission, and then some pictures of a planet, or let's say the scientific results at the
Hmm.
end of the mission. Um, they don't have this understanding that, in fact, spacecraft don't work automatically on their own. Spacecraft are very complex machines that, from the moment they separate from the launcher, which is maybe half an hour after liftoff or an
Hmm.
hour after liftoff, from that moment until the end of the mission, they have to be continuously told what to do.
Hmm.
And so there is mission operations means the people that on ground basically remote control the spacecraft. They tell everything to the spacecraft, not only pilot them in the right
Hmm.
orbit, to the right trajectory, to the target, but also do all the things that the spacecraft have to do, even just taking a scientific picture of
Hmm.
a target, which can be on Earth or another planet,
Hmm.
is a very complex process that has to be planned in advance. All the instructions have to be prepared, have to be sent via radio signals to the spacecraft, and then the spacecraft executes them. And of course, once the picture is taken, then the spacecraft has to send back the picture via radio signals. And so our task is to keep an eye on the spacecraft continuously because,
Hmm.
again, it's a complex machine and it has to be monitored in all its aspects. Maintain the right environment, the pointing, the attitude, the thermal environment, and so on.
Hmm.
But also execute all the activities. We uplink to a normal mission thousands of telecommands, which are what we call telecommand is instructions
Hmm.
that the computers on board have to execute in order to do their mission. And of course, the other part of the task is collecting all the data produced and
Hmm.
distribute them to the user. So it's a central task because without operations, the satellites would be abandoned in space, and that's we are the link between the users of the mission, which
Hmm.
can be scientists or can be users of an application,
Hmm.
and the spacecraft.
In your 2023 book, The Challenges of Mars, you highlight the heavy administrative procedures NASA introduced into the Mars sample return collaboration that was supposed to retrieve the samples that the Perseverance rover have collected. Could you unpack what became of ESA's momentum in getting its rover onto the Martian surface, and what has this experience revealed about the cultural differences in how NASA and ESA handle mission operations and risk?
Um,
In getting its
well,
rover
okay, there are the multiple return mission
revealed
has
about the culture
actually
and ESA
gone
handle mission
through several different difficulties, which are partially financial, partially technical.
operations.
The mission started very well as a example, a good example of a cooperative mission. So
Hmm.
you take on both sides of the ocean the best competencies, you
Hmm.
put them together, and you don't duplicate, say, activities. You just use the the best experience on either side of the ocean. For example, of course, NASA is much more experienced than ESA in landing on Mars.
Hmm.
We've not achieved a successful landing on this side of the ocean,
Hmm.
landing on Mars. But on the other side, ESA has a lot of experience with long duration solar electric propulsion missions, like we're
Hmm.
doing Bepi Colombo
Hmm.
today to Mercury,
Hmm.
started in 2018 and still flying. So the the contribution of ESA, one of the main contributions, is actually a solar electric propulsion mission that gets to Mars, collects the sample that are delivered in orbit by the NASA counterpart, and brings them back to Earth. So we do with the part of the mission that we are good at, and NASA does, of course, the part of the mission they are good at, like the landing on Mars, the surface operations. Having said that, of course, you have to put together, you mentioned correctly, the cultural differences. We have a long experience of a cooperation with NASA. So actually, these difficulties we know how to deal with. We know also personally many people on each side. And so we have built also personal relationships that help overcoming those. But yeah, more difficulties have been introduced in the years. This not only with Mars Sample Return, it came much earlier. There are regulations introduced in the US that actually put a lot of obstacles in, say, distributing information,
Hmm.
sharing information. And this is something that we had to learn with the years to work with. And sometimes it's not easy because
Hmm.
ideally, when you work cooperating between us and NASA and ESA, you would like to be completely free of sharing information. On the
Transparency.
other hand, I understand also that there are issues on sensitive information. Of course, on both sides, we have to take care of our industry and take care of their IPRs, property rights. So it's also our duty to defend them. So that makes things
Hmm.
a bit more complicated. But okay, I guess it's a fact of life, and we have to
Yeah.
live with it. Yeah.
Yeah. True. Okay. Let's now shift gear to China. You've written in the same book that during your 2017 ESA trip to Shanghai, you were being surrounded by Chinese delegates eager to learn from ESA's Martian missions, which made it clear to you that China's interests from back then, 2017, was already shifting away from the moon towards Mars. Which specific strategic choices do you think allowed China to catch up to and potentially surpass other major players in such a short time?
I it's actually a bit difficult to answer this question because my view, and I guess the view of most of the people on in the West of what happens in China is limited.
Hmm.
Also because of lack of information, and so I can only guess. And one thing, well, if guess on the base of things that I've seen, and one thing I've experienced was actually on the moon program
Hmm.
was an approach which was steady progress, adding one step at a time with a very timely approach. So, very rarely there would be delays introduced in the program. And each step was a reasonable step, not too long, not too short. So, technologically, I mean,
Hmm.
every new mission added a little brick to the wall. And I observed, because we actually supported the Chinese robotic moon program from
Hmm.
basically in the last 20 years. Yeah, I think we
Okay.
started early 2000s, in the first decade of the 2000s, and we saw how they systematically adopted this approach of the little steps, taking care of making them on time. So not exaggerating, not too ambitious steps, such that they would occur on time. And the same approach, I think they've adopted. Well, in fact, with Mars, one could think is different, because they did one mission and they did it all in a mission. They did orbiting, landing, rover in one mission at the first
Hmm.
attempt. But in fact, they adopted techniques that they had developed for the moon.
Hmm.
So the only, if one thinks a bit more about this first mission to Mars, the only add on to that mission compared to what they had already done successfully on the moon was the fact that they had to bring the spacecraft to Mars. But everything else had been done on the moon. And I think the same approach has been taken for a future mission, which will be the sample return.
Hmm.
They have already tested around the moon
Hmm.
twice the sample return techniques, proximity operations, and so on, which they will need at Mars. So I think this very solid and systematic and timely approach was the key. And that's why you could see well, you mentioned 2017. Early on, you could see, okay, now they've tested enough on the moon. The moon
Hmm.
program will continue, but
Hmm.
they have now taken the shift towards Mars. And I think, yeah, I would judge that in the next few years they will adopt this stepwise approach also on Mars.
Okay. I think in planetary exploration, returning a sample is a milestone. Um, Maybe China could potentially bring back Martian soil before NASA or ESA. Do you believe Western agencies might have underestimated China's capabilities? And what would it mean if China indeed wins that race of bringing soil to back from Mars to Earth?
I must say, I think we have been underestimating their capabilities in the beginning, in the sense that we have this sort of, say, prejudice about Chinese, or they only copy what exists.
Hmm.
And I'm convinced from my very limited experience, but I'm convinced that this is a wrong prejudice. Yes,
Hmm.
if you want to put it in a negative way, they copy in the sense
Hmm.
that they don't start, they start from things that exist, but they improve them. So I think since many years, certainly in ESA and in Europe, but I'm sure also in NASA and in the US, they've realized that China is making big advancements, and that they are, well. I don't think anybody underestimates them anymore.
Hmm.
Um, so, in fact, I think the competition is on at this time,
Hmm.
especially between the US and China. It's also a prestige
Hmm.
competition, similar to what was for the moon landing, the human moon landing in the 60s between
Hmm.
US and USSR. So the competition is on. Both parts are very well aware that they could lose the race.
Hmm.
And, well, frankly, today, okay, things can change, of course. Today, with the difficulties that the European American Mars Sample Return mission is having,
Hmm.
well, a lot of people think that the Chinese will get there first
Hmm.
on a prestige, say, target.
Okay.
If you look at it from a scientific point of view, the certainly the Mars Sample Return that we are putting together on the western side is a
Hmm.
much higher value. The Chinese would go there, collect some samples, and go back. Our sample return is based on a very long duration work of perseverance on the surface of Mars. The samples have been collected with a very heavy scientific work behind. So I think
Hmm.
scientifically, this sample return our sample return would be much more value. But from a prestige point of view, to your last part of the question, you said, what would it mean if they get there
Hmm.
first? Well, it would be certainly a very important step for China to show that they can do things well faster
Hmm.
and at least as reliable as the ones on the West. Yeah,
Okay.
scientifically it would be a different thing, but on the news it would make a big
Okay.
wave. Yeah.
Okay. So, okay, great. Let's now shift gears to the private sector. So, as we see SpaceX, Blue Origin, iSpace, Firefly Aerospace now, and other commercial players take a role, uh, a role that is once reserved to the national agencies. Do you think private companies can truly match the depth of reliability and thoroughness traditionally associated with agency-led missions?
Um, let's say, I think that there is not a yes or no answer to this, because um, even in the past, and now the process is even faster,
Hmm.
we've always observed that the say institutional agencies tackle a new field of space
Hmm.
where the experience is zero, the risks are very high, the revenue is basically not there. They
Hmm.
tackle this, they de-risk this sector. Look at telecommunications, for example.
Hmm.
Once the level of risk is low enough and the potential revenue is high enough, then the commercial sector comes in.
Okay.
And I think this, as I said, it started with the telecommunications. Now, yes, the agencies still do communication, the new, say, new concepts and so on, but the bulk of the telecommunications is done by industry.
Hmm.
Nobody needs an agency to send in space a telecommunication communication satellite. The same as happened with Earth observation, meteorology. It will go on with other sectors.
Hmm.
So I think it's a matter of seeing these two roles being complementary to each other. The agency with a more mature and more interested and to take over responsibility industry,
Hmm.
they should let them take it. But industry only goes in when when the agency has done the de-risking work. Yeah?
Okay.
Or at least that should be the rule. Uh, the agency still, even if a sector is left, the
Hmm.
agencies should keep again the role of pioneering new fields which
Hmm.
are too risky and not say not lucrative enough
Hmm.
for the commercial companies, and also try to keep a role of regulation, for
Hmm.
example imposing standards, also imposing guidelines and rules
Hmm.
to the commercial world, which otherwise would might develop in a sort of wild way. Yeah?
Hmm.
But the two worlds can, and have done also in the past, can complement each other and have should complement each other.
Okay. Let's now zoom a little bit further down from in orbit assembly to manufacturing to in orbit servicing and logistics. The next frontier poses new layers of mission design and operational complexity. Which operational pitfalls worry you most, and do we in Europe have the right frameworks or talent pipelines to handle these unprecedented challenges?
Um, it's actually, here I'm touching a field where I'm not so familiar with, because it's a
Okay.
very new field. So let's say all I can tell you there are certainly aspects that I've been involved with, which is for example proximity operations,
Hmm.
and I know that these are fields where definitely Europe has the capabilities,
Hmm.
industry has the capabilities, and I don't see any difficulty in getting into that. Proximity operations means, for example, in orbit servicing, you need to do that. Yeah.
Hmm.
Now, the technology of depending on the service you want to provide, like in orbit refueling and so on, I'm not really able to judge. But I have also there, I would say, I would be very surprised if Europe would say no, no, it's too difficult for us, or our know-how and technology is too immature. So I think Europe has the certainly the resources and capabilities to get into that field
Hmm.
equal to Chinese and US.
Hmm.
The only thing where I see maybe we are in a in disadvantaged position is that especially for this type of operations,
Hmm.
the Chinese and in particular the US are investing a lot from the military side, and that's also the reason why I'm not so familiar with that, because you don't hear
Hmm.
much about that. But there's a lot of investment, there's a lot of activities, because in orbit servicing and operations are very of high interest to the military. In Europe, we are behind there. I don't want to judge whether it's good or bad, but
Hmm.
certainly that slows down, let's say, the process of making our technology and our expertise more mature.
Okay. Um, yeah, thanks for sharing. Okay, let me ask you. You've seen missions where scientific goals had to be um, reined in by engineering realities. For entrepreneurs and startup founders in the audience, how do you strike the balance between pushing boundaries and respecting operational limits?
I've been exposed to this every day. And well, uh, let me just give a sort of principal answer, which might sound a bit superficial. Um, uh, we we have experienced this in many missions, and but there was the big example of Rosetta, where we were actually designing a mission to the unknown,
Mhm.
and we have the so it was very difficult before we got there to actually establish exactly what each side, yeah, the users, for example, the scientists and the operations people, would do, and where the boundaries were. The 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 key point was expectations management. When we arrived at the Comet, we had enormous difficulties to fly around the comet. Nobody had done that before. We
Mhm.
had to develop a model of the comet in order to orbit it. It was like flying while you were learning to fly, and so the risks were enormous.
Mhm.
And on the other side, the scientists, just when we arrived at the comet, they wanted to do science operations. They were like
Mhm.
kids, like kids at Christmas, open the toy, open the package, and
Mhm.
they wanted to play with the toy. And so what we established sort of guidelines in the field that I called manage expectations.
Okay.
We told the scientists, okay, that's the boundary where, let's say, the box where we
Mhm.
are going to operate in. This box may look to you too conservative and extremely disappointing,
Mhm.
but we will show you that whenever we can get into the box, we will
Mhm.
do it. And so we established the box, which was actually conservative,
Mhm.
and we told them, if we don't knock every day at the corners of the box or at the
Okay.
borders of the box. Let us do our work. And then we showed them daily that whenever there was a chance, we were getting in and letting
Okay.
them getting more into this box. This is a process that you don't develop from scratch. You have to build a lot of trust,
Okay.
and that's where communications
Mhm.
are fundamental.
Okay.
So you don't, with scientists or with your users, which is like your customers,
Mhm.
you don't work by just requirements, but you
Mhm.
work by trust. And so you develop this trust, and the day, if you have gained this trust and you have shown that you're willing to go to the limit, but
Mhm.
if you say that's the limit and beyond that, the spacecraft safety is at risk. If they've seen you doing that, then they trust you, and when you say no, they accept the no.
Okay. Just quickly on this subject of as a follow up, what is the highest risk factor that you had to consider in just the spacecraft? Was it the communication, the fuel, or the power, or was it the terrain?
In our case, was the environment, the
Hmm.
navigation, and the environment. So
Hmm.
two aspects. First of all, we had significant inaccuracies in the navigation,
Hmm.
and we wanted to avoid collision.
Hmm.
Collision with not only with the surface, which
Hmm.
was relatively easy to do, but collisions with even potential boulders around it, yeah, flying around the comet.
Hmm.
So there we had to maintain certain distances,
Hmm.
which were initially very conservative. The second aspect was the environment. So that was navigation, and the second aspect was the environment. The environment around the comet is very dirty. There's a lot of
Okay.
dust. There's a lot of gas, and this was causing even our attitude control enormous problems because the star
Mhm.
trackers, instead of seeing the stars, they were seeing sort of snowstorm,
Okay.
um, and so we had to modulate that, the distance to the comet, for example, or certain orbits that would allow a, say, a better illumination, a more favorable illumination of the dust, and that would not disturb our star trackers. And this was a big fight because the scientists wanted to be closer.
Hmm.
We showed them. We actually did even a couple of attempts to go closer, and we showed them that the spacecraft would get at risk. So these two aspects: environment and navigation.
One last follow up. Again, I'm excited to
Yeah.
from your perspective. You've seen the landscape of the comet or the asteroid every day. What is it? What? How do you describe it? Is there what do you remember about it? Like, what is something that is like, okay, this is.
Yeah. Well, it's a very interesting question because what I remember, I mean, we've taken 400,000 pictures, yeah. So
Mhm.
don't ask me which one I prefer because this,
No, no,
but
no. But
your question is well formulated because what I remember of this
mhm,
was the astonishing, let's say, the effort I had to put with my mind. To not to be fooled by the pictures, because when
mhm,
you see a picture of the comet, you
mhm,
tend to interpret it as it were a mountain on the earth.
mhm,
And this is a completely false impression. The comet is so small that the gravity is very faint, of course.
mhm,
But the direction of the gravity is not perpendicular to the soil, because if you have a
mhm.
mountain next to you, it actually pulls you towards it. So your local vertical, if you're on this
Okay,
surface with a mountain here, your local vertical is not here. It's like this. Yeah. So
okay,
uh, it's all. Every time you look at one of these pictures, and you have to work with it because you want to
mhm,
to understand what is happening to your landing and so on. You have to force your brain not to interpret the picture through your common sense. You see
okay,
that landscape and you think, oh, yeah, that's an icy side of a mountain. It's not. It's another
okay.
world. Yeah. And that's what I remember. It was really a constant effort. Your brain wanted to go to your normal scheme, and your
Mhm.
normal scheme did not apply.
No, okay, no, very interesting answer. Um, okay, space missions unify scientists, engineers, and policymakers, and even multiple countries. From your experience, what best practices can leaders adopt to keep diverse teams aligned towards a single mission objective, especially when stakes are high and timelines are a bit tight?
It's a very important question, and I think with the European Space Agency we have a lot of experience with this because we are forced to
Hmm.
work with diverse teams. We have team members that, in principle, can come from 23, well, now 23
Hmm.
different nations, and we are forced also to work with very diverse industrial teams. Sometimes we don't even have the possibility to choose the ones we want.
Hmm.
We have to maintain this European perspective even in a single project. This may look like a strong constraint
Hmm.
and a big disadvantage. If you work well with it, and that's actually your question, you can turn it into an enormous advantage. For example, um, talking about the team building, when you build your team, yeah, you get take an aeronautical engineer or an
Hmm.
aerospace engineer from Italy, from Germany, from the UK. These people are completely different. Even if they have the same background, they are aerospace engineers, but they got a completely different cultural education.
Hmm.
And if you are aware of that, you can build a very strong team because you can take this diversity and put it on the right say task.
Okay.
If you're not aware of that, you can make two mistakes. One is that you put the wrong engineer. By the way, I'm talking about, say, aerospace engineers, but we have teams which have physicists, mathematicians, and so on,
Hmm.
but from different nationalities. If you're not aware of that, you can put the wrong person into the wrong task.
Okay.
That's one mistake. And the other mistake is you have to fight against this sort of inner thought that is, well, let's take everybody of the same nationality, then it's going to be easier. Yes, it's going to be easier, but it's not going to be the strongest team. The strongest
Okay.
team is a diverse team with a utilization made with awareness of the strength of each one.
Cool.
I don't know if I explained
No,
myself.
perfectly. No, thank you for your answer. Um, okay, so you've moved from running ESA's operations to teaching, mentoring, writing books, and advising companies. What specific projects or collaborations are you most excited about right now, and how would they shape the industry's trajectory?
It's actually interesting. When I left the agency, I didn't want to become a traditional industrial consultant. Yeah,
Mm-hmm.
I said I would just move into education. So I took, say, commitments with universities. I'm cooperating with the Technical University of Bremen, sorry, of Dresden, where I I teach some lectures in a course of interplanetary operations.
Mm-hmm.
That's something that excites me a lot because
Mm-hmm.
I deal with young people, and I can still tell my stories and to people that have not heard them any yet. Yeah. My colleagues were fed up of hearing my stories, uh, so that's very nice. I like writing the books where I can really share again my experience, and my books are becoming even more challenging now because I try to explain these things also to a public which is a bit wider than the
Mm-hmm.
relatively small community of space interested people.
Mm-hmm.
Um, but you were more oriented towards yeah, the future of space industry. Of course, I'm not influencing it anymore, but I've been exposed to consultancy work, to even to um, organizations that are simply funding space industry,
Mm-hmm.
and this is a very very interesting job because it exposes me to the startups and the small companies
Mm-hmm.
that are coming up like
Mm-hmm.
mushrooms these days.
Mm-hmm.
They have a completely different mentality compared to the one I've been used to work in the agency
Okay.
and with the traditional space industry.
Mm-hmm.
So I learn a lot from them,
Mm-hmm.
but I have the feeling that I can pass some of this experience, and that some of this experience, although the world is very different and their world is very different from the one I lived in, can still be applicable. And that's the part that actually excites me a lot.
Mm-hmm.
Again, I'm not influencing. I'm sort of yeah, going. I'm going along with them, and it's a very very interesting thing. But they are
So,
doing. I'm not deciding.
but from your experience, from those experiences, is there any like subsector that's developing that you're finding, okay, that's interesting, that's something we didn't do, and like if I was 20 years younger, I would, or 30 years younger, I would want to work on this because this has so much potential that you want to share.
Okay, well, let's say not the latter, in the sense that I'm very happy that I had to deal mainly with scientific missions
Mm-hmm.
and with interplanetary missions, and the development of new space today is more related to the applications, and
Mm-hmm.
therefore. Yeah, it's not that I would have preferred to work in this field. Having
Okay.
said that, it's exciting to see two aspects of these new approaches. One is the fact that with small satellites you can do a lot today,
Mm-hmm.
which for us it was unthinkable until maybe 10, 15 years ago, and therefore the flexibility you get into doing things with in doing things with small satellites is much higher than the one we had
Mm-hmm.
with the big projects I work with. Yeah, I worked on with spacecraft that take 8 years to develop, 500 million or maybe 300 million cost, industrial cost. So now with small satellites, you can do in a more flexible way things in
Mm-hmm.
space, at least around the Earth.
Mm-hmm.
And also you can also dare more because if we were extremely conservative, because one mistake would kill a mission that maybe lasted 8 years of preparation and
Okay.
half a billion. Um, you can dare more.
Okay.
In a specific field which I'm very excited is you mentioned it initially, this in orbit servicing. I think they can have a lot of fun there, yeah, with not only proximity operations but really dealing with the services like I mentioned refueling, but there's many others.
Mhm.
They're talking about even manufacturing in space,
Mhm.
and even recently I was talking to people who want to recycle
Okay.
satellite, recycle material, dismantle them and recycle. So all these things are very, very exciting. Yeah. Still,
Yeah.
I love the interplanetary exploration, and yeah, I would not exchange it for that.
Okay. So, with commercial space stations, lunar resource extraction, and ambitious planetary missions, as you said, which are looming on the horizon, how do you foresee Europe's role in the next era of human expansion into space? And to add to that question, do you believe in human expansion into space or just utilization and exploration?
um, okay, Europe's role. One has to let's start from the solar system,
Hmm.
and I think Europe is now capable.
Hmm.
The last 20 years we've developed this capability. We're capable to fly in the solar system, at least to Jupiter and Saturn. We
Hmm.
don't have yet RTGs, radioisotope generators, so we cannot go much further, but
Okay.
Jupiter and Saturn we can reach. And those are for me the frontiers, not only of Europe, also of the mankind, for exploration of the solar system, robotic exploration. And I think we can play a very, very, very strong role. We are doing it in these years with Jupiter, so we will get there in 2031.
Hmm.
And together with NASA, they will get there 1 year earlier. We will study the icy moons of Jupiter. Very exciting.
Okay.
The same will happen not too far in the future, maybe 1 decade later with Saturn. There
Mhm.
are exciting things there, Enceladus, Titan, and I think Europe can play a very, very prominent role. Yeah. If you come to Mars and Moon, there, the, let's say the step now, or let's say the phase we are in now, is actually trying to develop an infrastructure that will allow the next steps.
Mhm.
The pioneering work has been done on
Mhm.
both Mars and Moon, and now you can see in the US, in China, in Europe, there are efforts to think of infrastructural issues,
Yeah.
communications, transportation, mobility on the surface,
Mhm.
providing these as yeah, infrastructural support tools that then the next explorer can use, so they can actually concentrate on the effort of the exploration and not
Okay.
have to build every time the same the same tools for
Okay.
transportation, for mobility, for communication. So we are working on that, and I think Europe can play a very big role there, even if maybe not a leading role. The costs involved are enormous in
Mhm.
both cases. So those are the two frontiers. When we come to Earth orbit, I think that's a bit more complicated. There is
Yeah.
now a lot of commercial interest. There is military interest. I think that's a bit more difficult to handle. But those two things are the places where Europe can play a big role. To the last part of your question, human exploration. I
Versus
think,
human expansion.
oh, human expansion even. Okay,
Yeah.
so
So
okay.
where do you stand?
Okay, already human exploration, I see it as certainly necessary,
Mhm.
but as something that comes much, much slowly and much later. Look at this. Look at where we are today. After 60, 70 years of space age,
Mhm.
we have been everywhere in the solar system, to the borders of the solar system with robotic missions, and with humans we've been at, well, we are now at 400 kilometers. We have
Mhm.
been occasionally there on the moon, but we will always be very much behind, and it's fine, it's
Mhm.
correct. Is Incorrect would be to give it up,
Mhm.
but it will always be slow. If you then go to expansion, I think I think it's still in the realm of science fiction.
Okay.
I cannot imagine a colonization. I hate the word, but okay, you use the right word, expansion of mankind on the moon, on Mars, I don't believe this will happen.
Okay.
Certainly not in a short term. I believe in Moon and Mars as steps for a
Mm-hmm.
further exploration.
Mm-hmm.
Maybe one day we're going to do interstellar travel, and there maybe it will make a bit more sense. Yeah, but
Okay.
Moon and Mars are not places for mankind to live.
Okay.
They're going to be
Mm-hmm.
test cases, and maybe live short for a short time there.
Okay.
Expansion to that, yeah I yeah can't imagine.
Okay. Cool. So, what are some overlooked areas in the space industry that people need to start paying attention to, and why?
I I I can mention one,
Mm-hmm.
which I'm very disappointed by the extremely slow progress in development of propulsion systems.
Mm-hmm.
If when I was a kid in the 60s, in the 70s, there were ideas, research projects, and funds into many different propulsion systems that at that time looked very futuristic.
Mm-hmm.
Today, they're still at that stage. Actually,
Mm-hmm.
the funds have not been well, have been cut practically. So
Yeah.
if you look at it, we are still using the same propulsion systems with minor things like the solar electric propulsion has started, but fine,
Mm-hmm.
this is not a revolution. We're still
Mm-hmm.
using the same propulsion system that we were using in the 50s for rockets,
Mm-hmm.
for spacecraft, and the reasons are multiple.
Mm-hmm.
One of them is the fact that yeah we went more towards the miniaturization rather than so we launch things which are always smaller, which is also good. So there's not much need for bigger propulsion systems. But if we
Okay.
want to make the next step, we need revolutionary propulsion systems. For example, if you want to go to Mars today, the
Mm-hmm.
real problem, or with human beings, the real problem is that the trip takes, well, overall 2 3 years.
Mm-hmm.
It poses enormous health risks, which today are not acceptable.
Mm-hmm.
If the trip would take 3 months, then we could do it.
Okay.
From all these other aspects. So I think propulsion is the place that, for me, I'm mostly disappointed that there's not been an evolution and the progress.
Okay, Paulo, for students, engineers, and entrepreneurs dreaming of joining the space sector, what core competencies or mindsets do you consider absolutely indispensable in mission operations today?
Yeah, in that's also an interesting question. Let me start with the mindset.
Hmm.
Um, Mission operations is a true system engineering endeavor. Practically, you have to have the mindset of somebody who wants to go on the surface across a very wide range of topics,
Hmm.
but can say is not frustrated by the fact that beyond the surface it cannot go very deep. I've
Hmm.
met in my career fantastic engineers
Hmm.
who were always frustrated in mission operations because they couldn't go down deep, down to the very bottom of the
Okay.
problem. Mm, if you want to work in mission operations, you have to understand that daily you will be confronted with decisions where you have limited time to take them and insufficient information to take them. So, at least not enough as you would like to. So, you have to
Okay.
live with that. And if you have the wrong mindset, you say, no, before giving an answer, I want to know everything, then don't work in mission operations. In terms of core competencies, apart from that's something I would tell anybody, even if you want to work in a washing machine company. Learn mathematics because that's something that we use every day, and I think that everybody should use it every day in his life. But apart from that, mission operations is a place where you can apply a surprisingly wide range of competencies.
Hmm.
I'm not well. I'm not saying that we can use very much of a biologist, but I'm sure that even a biologist would have some application in our daily work in operations. A philosopher. So I'm talking about
Yeah.
uh, experts which are, in theory, very far from us. Typically,
Hmm.
we are engineers of all kinds. We are physicists. We are mathematicians, we are informatic engineers, telecommunications. But the nice thing of mission operations is that the more diverse the competencies are, the better your team can be.
Yeah, I think once you have, once we find organic life, whether complex or simple, then philosophers, ethics will also be introduced
Absolutely,
into mission operations.
absolutely, absolutely.
Cool. So finally, looking ahead, where do you see the extent of our space exploration 15 years from now, like in 2040? Also, where do you hope to see the extent of our exploration 15 years from now?
I think already 15 years is not a very long, say, horizon.
Hmm.
Therefore, I think it's what I mentioned before, exploring the Jupiter and Saturn systems
Hmm.
properly. For the
Hmm.
moment, okay, Jupiter, we have had 9 missions going there.
Hmm.
Saturn, much less. I think
Hmm.
practically, I think 3 have flown by. Well, there's only been an orbiter, so that's the frontier for the solar system exploration, because those are the places where I'm extremely excited to go.
Hmm.
It will not be me, but I'm sure that in the next 15 years that will be possible to do. And these systems require, from a scientific, but also from a pure exploration mindset, require a lot of work. These
Okay.
are not just a planet, just a moon. These are complex systems from which we can learn a lot about our planet, about the solar system, and maybe about also life in the solar
Hmm.
system. So I think that's really the frontier for the next 15 years, maybe even a bit longer.
Okay.
And I'm more excited by that than by Mars and Moon, where
Okay.
Mars
It
and Moon,
shows.
for me, they are beyond the exploration step. Yeah,
Hmm.
Mars and
Hmm.
Moon are in a consolidation step,
Okay.
while those places are really the
The
new
frontier.
frontier.
Yeah.
Yes.
So before we wrap up, is there anything else you'd like to share with our audience? I should mention that you've had a new book published this year, right? Flying Beyond the Sky: The Secrets of Space Exploration. Unfortunately, it's still in Italian. I hope to see it translated to English, like we spoke the last time we spoke. So because more people can learn, enjoy, and appreciate your contribution as we do, as I do.
Yes. Yeah, no, I would like definitely these books to be translated. Actually, I realized that I was not familiar with that world.
Hmm.
That is not so easy,
Hmm.
especially in English,
Okay.
because there's such a huge production in
Hmm.
original English that the English publishers are not very attentive for the
Okay.
translations. Yeah. So I think, yeah, I keep making my efforts for English, for German, but it's not all in my hands. Yeah, I depend on
Sure.
my publishers, and but I'm looking forward to that as well. I'm sure. I keep hearing from colleagues, from friends that they would like to read it in English. My only answer today is learn Italian.
Yeah, or Google Translate. I copy paste, make photos of the digital, and then
Ah,
translate it.
right,
That's how I do it
right.
to be
Yes,
able to
yes,
prepare for
yes,
this interview.
yes.
Okay, Paolo, it's been an honor to have you here. Thank you so
Thank you.
much for sharing your insights and expertise. I'm sure our audience will greatly benefit from your knowledge. To everyone else listening, this is Omar Alaili podcast, and thank you for joining us and keep exploring.